All right, here's a quick video on special right triangles. We've got two triangles that are very special. The first triangle is a 45, 45, 90. The reason why this guy's so special is because it's half of a square. So if we take a square here and we cut it right down the middle with a diagonal, we get a triangle, a right triangle. And this right triangle has two 45-degree angles because we know that when we have a diagonal in a square, it bisects the angles. And so this guy is now our 45, 45, 90. Okay? And we find out that something's very special about it. And what happens is, whatever these legs are, if these are 3, well, they both got to be the same, first of all, because it's a square. And if we take that and we multiply it with our Pythagorean theorem, 3 squared plus 3 squared equals c squared. Well, that's going to come out to be 18, and that's going to come out to be the square root of 18, and the square root of 18 simplifies to the square root of 9 times the square root of 2, which is 3 square root of 2. Okay, so all of that, and we end up with 3 square root of 2. And it turns out that it will always be the square root of 2 times bigger. So if you take any 45, 45, 90, it's going to be similar to this guy. And so the legs will be the same because it comes from a square, and the hypotenuse is the square root of 2 times bigger. Pretty slick. So two things are true about 45, 45, 90s. The legs are equal. It's isosceles. It's an isosceles right triangle. And the hypotenuse is the square root of 2 times bigger than the leg. Square root of 2 is about 1.5. Yeah, it's close to 1.5. It's actually 1.414 is closer if you plug in your calculator. So we're just saying that the leg, or the hypotenuse, is 1.4 times bigger approximately than the leg. Okay, but exactly the square root of 2 times bigger. Pretty slick. Now with that, we can find some missing parts. So here we have a right triangle, and it's a 45, 45, 90. Ooh, we know that that comes from half of a square, right? Okay, so we should be kind of visualizing that square. And we know that since it's half of a square, then this guy has to be 3. And then we know that, well, we happen to just did this one a few moments ago, but even if we didn't, we know that we can find the hypotenuse by multiplying by the square root of 2. So this ends up being 3 times the square root of 2. Done. So the sweet thing about special right triangles, about these 45, 45, 90s, is we don't have to go through the whole Pythagorean theorem. We could if we wanted to, but this is always going to be the square root of 2 times bigger. Okay? All right, well, what if we got something like this? Uh-oh. What if this side's 6 square root of 3? It's an irrational number. Well, that's okay. We can take this. We know this one's going to be the same, right? So this is going to also be 6 square root of 3, which just means 6 times the square root of 3, which is some decimal number. Go punch on your calculator. If you wanted a decimal, you could get that. Well, how do we find the hypotenuse? Well, we take the leg times the square root of 2. So this is 6 square root of 3, which means 6 times the square root of 3 times the square root of 2. And we can multiply radicals. So square root of 3 times the square root of 2 is the square root of 3 times 2. We can put them together. We get square root of 6. So this is 6 times the square root of 6. That is C. Okay? All right, so if the legs are rational or irrational, either way, we can find the missing side by multiplying by the square root of 2. Well, as we just saw a few times there, the hypotenuse is the square root of 2 times bigger. So whatever A is here, I don't know what the leg is. The leg is A times the square root of 2. Well, can you solve that little equation? I think we can. Square root of 2 is just a number. We can divide by the square root of 2. So we end up with A is 5 divided by the square root of 2. See that? So A is 5 divided by the square root of 2. And you go to your calculator, 5 divided by the square root of 2 is just some decimal number. You get that. But we wanted this to be exact. So that's pretty close. That's almost the right answer. We just want this to be simplified. Okay? And so we want this to be simplest radical form. So to do that, we need to multiply by the square root of 2 over the square root of 2, which is just 1. Okay? So we get 5 square root of 2. And the square root of 2 times the square root of 2 on the bottom here is just square root of 4, which is 2. There you have it. Okay? Or if you want, that's like 5 divided by 2, which is 2.5. So, we could say this is like 2.5 times the square root of 2 if you wanted to. We usually don't, but it kind of is. Okay? So this is 5, and this guy's going to be the same, 5 square root of 2 over 2 for B. Okay? There you have it. Okay? So if we are looking for the hypotenuse, we multiply by the square root of 2. If we're looking for the leg here, we're going to divide by the square root of 2. So what we really did was we went backwards. We divided by the square root of 2. Okay? Well, let's look at one more special right triangle, the 30, 60, 90. Well, our last special right triangle, the 45, 45, 90, was half of a square, which is an equilateral, quadrilateral. Well, now let's take an equilateral triangle. Okay? So if we have this triangle is equilateral, all sides are the same here, okay? And we cut it in half, we get a special triangle. Well, the equilateral triangle is special by itself. That's special, but it's not really a right triangle. Remember, the angles in an equilateral triangle are all 60. So 60 degrees here. So this guy's 60, this guy's 60, and this whole thing is 60. But when we draw this perpendicular altitude here, that's going to cut this angle in half. It's going to be the angle bisector also. And then we get this guy, which is, oh, look, all the things came with it. Okay, so this guy is half of an equilateral triangle. Okay, and the angles are 30 degrees, 60 degrees, and 90 degrees. Okay, so this is our 30, 60, 90 right triangle. And we get some special properties of it. Let's kind of come over here. You can kind of see them there, but let's pretend like we don't know those for a moment. Okay, since it comes from that equilateral triangle that we just saw a few moments ago, we know that this guy down here has to be half of this one. Okay, let me draw that. Okay, so there's our equilateral triangle. We know that this guy has to be half of that one, right? Okay, and so if this is 5 here, that this guy has to be 10, right? Because that would be our equilateral triangle there, right? Okay, and then we can use some Pythagorean theorem to find this side here, like 5 squared plus b squared equals 10 squared, and that's going to come out to be 100 there. That's a squared. And so if we subtract 25, we get 75. And if we square root, we get the square root of 75. But the square root of 75 can be simplified. That is the square root of 25 times the square root of 3. So this is 5 square root of 3. Well, that's kind of interesting. So this guy is the 5 square root of 3. It's a square root of 3 times bigger than this one. And we're going to find out that that's always going to be true. Okay, so let's jump back here. Okay, so the moral of the story is this. Since this is half of that equilateral triangle, okay, again, the hypotenuse is going to be twice as big as the short leg. Okay, so we're going to always start with this short leg here, all right? So this is going to be twice as big because it comes from the equilateral triangle. And because all these 30, 60, 90 triangles are similar, this long leg is going to be the square root of 3 times bigger than the short leg. Okay? So whatever this is, we can get to the long leg and the hypotenuse from the short leg. So it's all about the short leg. We want to find the short leg. Okay. So that's the key. Okay? The theorem is this. Okay? If it's a 30, 60, 90 triangle, then the hypotenuse is 2 times the short leg, and the long leg is the square root of 3 times the short leg. Okay, So we'll keep that in mind there, all right? So here's the idea. Here we have a 30, 60, 90 triangle. This is the short leg. So how do we get to the short leg from the hypotenuse? Well, we double it. So this is going to be 2 times 2, which is 4. So the hypotenuse is 4. That's it. Okay? Now notice, by the way, we can't use the Pythagorean theorem here. Okay, let's back up. Look at that triangle. You only have one unknown value. So you can't use the Pythagorean theorem. You can write it, but there's 2 unknowns. Pythagorean theorem is not going to help you. Okay? So again, we double it. This is going to be 4. Okay? And that was by times 2. Now to get down here, we're going to multiply by the square root of 3. So we have 2 times the square root of 3. And that is 2 times the square root of 3. Done. Okay? You can punch on your calculator. 2 times 7 square root of 3. It's about 3.4. So, okay? That's it. Well, what if we know the hypotenuse? This one's a little more challenging. Remember, this comes from a equilateral triangle. So if it helps, you can kind of draw it out. So that means all the sides of the equilateral triangle are 10, 10, 10, and 10. Well, if this whole side is 10, then this is half of it, right? Okay, so we know that the short leg is twice as big, but we're going to go backwards. So instead of multiplying by 2, we're going to divide by 2. Okay, and so this is 5. And now once we know the short leg, we can find the long leg times the square root of 3. And so this is 5 times the square root of 3. Or 5 square root of 3, we say. There it is. So if we know the hypotenuse, we can go backwards. Always want to go to the short leg. We're never going to go from the hypotenuse to the long leg. Always go to the short leg and then go to the long leg. Okay? So if you don't know the short leg, go find it. Well, here's one. We don't know the short leg. Okay? But we know the long leg. So again, we're going to want to go find that short leg right away. Okay? Everything relates to short leg. So what's the relationship between the long leg and the short leg? Well, we know that this guy is a square root of 3 times bigger. So 6 is x times the square root of 3. So how do you find x? Well, we divide by the square root of 3. And so x is 6 divided by the square root of 3. But we don't want to leave it that way. That's pretty much correct. We're going to rationalize the denominator, multiply top and bottom by the square root of 3, and we end up with 6 square root of 3. And on the bottom, square root of 3 times square root of 3 is 3. Ooh, this one cleans up because 6 divided by the square root of 3, we know that. That's going to be 2. So this is going to be 2 square root of 3, and that is the short leg. So here we divided by the square root of 3 to get there. And now, last but not least, to get to the hypotenuse, we're going to multiply by 2. And so 2 times 2 square root of 3 is going to be 4 square root of 3. Okay? So those are 3 different situations. Okay? If we know the short leg, we can go find the other 2 pretty quickly. That's easy. This one's kind of a medium difficulty. If we know the hypotenuse, go find the short leg and then go find the long leg. If we know the long leg, well, go find the short leg by dividing by the square root of 3 and then multiply by 2. Those are the 3 different kinds of problems you'll see when working with 30, 60, 90 triangles. Okay? Hope that helps. And get used to these guys. They show up all over the place. They're so handy because just by knowing one value, if it's a special right triangle, we can find the other 2 real quickly. Very nice, very useful. All right, keep it up.